Okay, we're going to end up with a little bit more practice here. We're going to do these two exercises. We're going to write some code to determine if an array contains any duplicate. So here is your method header, has duplicates, returns a Boolean, takes in an integer array. So I'm going to encourage you to again pause the video right now, work on this method on your own. This is a kind of a really good practice about thinking about arrays, thinking about loops, encouraging you to think about a nested loop. So again, pause the video, try to write this method, and then come back and we'll do it together. Okay, so we are going to write a method for has Boolean, has duplicates. Okay, so what can we do to figure out if an array has any duplicates? Well, we want to essentially, we're going to loop through the array, but we don't know anything, we don't know if our array is sorted or anything like that, so we can't take advantage of any of that. So essentially what we need to do is at each position in the array, we need to look at sort of every other element in the array to find out if it's a match, right? And if it's a match, then we know we're done. We found a duplicate. If we looking through the whole array and we've never found a match, then we don't have any duplicates because we've finished, we never found one. So what we can do is I'm going to specify my return result has dupes, and I'm going to start out assuming that it doesn't. So we're going to start out saying we're going to assume we don't have any duplicates, and if we find a duplicate, we'll change this to be true. Okay, so I'm going to go through my array. So my current number is numbers at I. Okay, so I'm taking a look at the current number, and I want to look at every other number in the array to see if it's a match. Well, there's a couple different ways I could do this, but I think pretty much you need to use a nested loop for this. Okay, so a lot of times if you want to kind of take a double look at your array, or you need to sort of look once through to get some information and look a second time through using that information, that requires a nested loop. So I'm going to have a nested loop here. I'll use J. Now, one option is I could start my loop in the same way. So I could have my inner loop use the same variables, the same indexing as my outer loop, just go from beginning to end. And then I could say, I'll call this my inner number. Okay, and then I could say, okay, well, at any point, if my current number equals my inner number, then we found a duplicate. Okay. Now, what's the flaw in this? Well, every single time we invoke this method, it's going to return true because at some point I and J are going to be equal to each other, and so at that point we're looking at the same number in the same position, and so of course current number is going to be equal to inner number, but it's not a duplicate, it's the same position, right? So that's a problem. So we could change that. We could say, well, let's make sure we're not looking at the same index. So let's make sure that I is not equal to J and the two numbers are equal. So if I is not equal to J, that means we're looking at two different indices. And then if they have the same number, well, then we really do have a duplicate. So this code is now correct. This will work. And then down here, outside of my loops, will return whether it has a duplicate. Okay, so this will definitely work, but it does a little more work than we need it to do, right? Because if we're starting out, let's say at position 0, and we compare the element at position 0 to every other element in our array, and we don't find a duplicate, well, then the outer loop moves up and looks at position 1. Well, do we really need to go back and compare the element at position 1 to the element at position 0? We don't, right? Because we already looked at the element at position 0 and we know it doesn't have any matches. So we're doing more work than we need to do. So although this solution is correct, I'm going to optimize it a little bit, and I'm going to say instead of starting J at position 0, instead I should start it at what? I'm going to start it at I plus 1. Okay, and now if I do that, I actually don't even need to have this extra I equals J check because we're always starting the inner loop one past where we currently are. So now this will do a little bit more work, a little bit less work to accomplish the same correct result. And actually I can do a little bit even less work than that. because essentially, once I find a duplicate anywhere I am, I want to stop. I can exit my loops, right? I can stop looking because as long as there's one duplicate, I'm done. I can just return true. So I can add a second condition to my loop here, and I can say, well, as long as I is within range and we don't have any dupes, that means keep going. Same thing on the inner. As long as we haven't found any duplicates, then keep going. But what this allows me to do is that as soon as has dupes is true, not has dupes will be false, so the whole condition will be false. We will exit the for loop, we'll then exit this for loop, and then we're done, and we'll just return. And if we get through all of the loops without ever resetting this to true, it'll be false like it initially was, which is correct, and again, we'll return the right value. Okay, the last practice we're going to do, the second one here, we're going to write a method to double the elements that are contained in an array, and we're going to do it in two different ways. One way where we actually want to double the elements in the array itself, and one where we want to create a copy of the array with doubled values. So let's create by starting, we'll create a test array. 1, 3, 6, 8, 4, 2. Okay, and now let's write our method. So I'm going to write my double values. Okay, so this is a method where I want to actually pass you this array and you double the values that are inside that array. So remember, if I send this array, so if I invoke double values with my test array, what is getting passed with test array? It's the value of test array, and what is test array's value? It's a memory location. So remember, if I invoke this method, array and test array are aliases of each other. So any changes I make inside of this method to the formal parameter array will also affect the actual parameter test array because they're the same object, they're aliases. Okay, so that means I can just go ahead and modify array internally to the method like I would if I was outside the method. Okay, and that's all I have to do. So let's print this out. Before double values method. Okay, so, and we'll then print it after. So there we go. We can see all the values have been doubled, which is good. That's what we wanted. But let's say now we want to create a new array, but we don't want to change the parameter. So we want the parameter to remain unchanged. So we need to take a different approach. Essentially, we need to create a new array. And how big should it be? Well, it should be however as big as our parameter array is. So array.length. And then we can go through in our loop, create a loop that cycles over the length of array, which is the same as new array. So we actually could use either. And we want to say, well, new array at position I gets array at position I times 2. And actually the return type for this should be int array. And then we'll return the new array. So now let's say our int array test array 2 gets create new double array, sending in our test array. And if we print the original test array, it should not change its value. That would be good. But of course, test array 2 should. And we see that's what happens. Okay. So a couple more examples of using arrays as parameters. Again, remember that when you pass an array in as a parameter, any changes you make to that array inside the method will affect the actual parameter outside the method.